Have you ever stopped to think about the microwave oven? It's a magic box in your kitchen. You put cold food in, and a minute later, it comes out steaming hot. It feels like something from the future. A piece of technology so common, we forget to ask the most important question. What is happening inside that box? The answer is not just about heat. It is a story about invisible energy, a special kind of wave, and a clever trick of physics that makes your food cook itself from the inside out. You watch it go around and around through the dark glass. The light is on inside, but you do not see anything that looks like a source of heat. Yet you know that when that timer hits 0, the soup will be perfectly warm, ready to eat. The cold ceramic bowl will have transformed into a vessel of bubbling, hot liquid. This everyday moment holds a fascinating scientific secret. We are so used to it that we rarely question the process. We just trust the magic box to do its job. The first big puzzle to solve is where the heat comes from. An oven uses heated air. A stove uses a hot surface. Both transfer heat from the outside in. Microwave does neither. The air inside the box does not get hot. The walls of the oven do not get hot. The heat appears directly inside your food. This is the hidden problem that scientists and engineers had to solve. How do you send energy into food that can become heat without heating everything else around it? The name of the appliance gives us the biggest clue. The box works its magic using something called microwaves. These are not some new invention. They are a natural part of our universe, an invisible force that was harnessed to change the way we eat forever. To understand what a microwave is, you first have to picture the electromagnetic spectrum. It is a giant family of energy waves that travel through the universe. Other waves in this family include X-rays, which let doctors see your bones, and infrared waves, which you feel as warmth from the sun or a campfire. Microwaves are just one member of this big family. They are a type of radio wave sitting on the spectrum between the radio waves for broadcasting and the infrared waves we feel as heat. Inside your microwave oven, there is a device called a magnetron. Its job is to generate these special waves at a very specific frequency. When you press start, the magnetron fires these waves into the metal box. The metal walls are designed to act like mirrors, reflecting the waves and bouncing them all around. The waves fill the inside of the oven, creating a field of invisible, oscillating energy. But this energy is not heat. Not yet. This is where the second part of the secret comes in. The microwaves are the messenger, but they need something inside the food to talk to. That something is water. Almost everything you eat, from soup to pizza to vegetables, contains a significant amount of water. To understand why, we need to look at a single water molecule. You probably know its chemical formula, H2O. That means 2 hydrogen atoms and 1 oxygen atom. The way these atoms are arranged makes the water molecule very special. It is a polar molecule, which is a scientific way of saying it acts like a tiny magnet. One side of the water molecule has a slight positive charge, and the other side has a slight negative charge. It has a north and a south pole, just like a compass needle. This polarity is the key. It is what allows the invisible microwaves to grab onto the food and start the heating process. Now let us bring the two parts of the story together. We have the microwave energy field bouncing around the oven, and we have the tiny water molecule magnets in the food. The microwave itself is an electromagnetic wave. This means it has an electric field that is constantly and rapidly flipping its direction from positive to negative. When this flipping electric field hits your food, it interacts with the polar water molecules. The positive end of the water molecule is pulled toward the negative side of the field. Then, in a fraction of a second, the wave's field flips. Suddenly, the water molecule is facing the wrong way. So, the tiny water molecule tries to spin around to align with the new direction of the field. It desperately tries to keep up with the wave's frantic flipping. That means the electric field is flipping its direction about 2.5 billion times every second. Imagine trying to spin around that fast. The water molecules in your food are being forced to wiggle, vibrate, and twist back and forth at an unbelievable speed. They are not moving from one place to another. They are vibrating furiously right where they are, caught in an energetic dance they cannot escape. This explains why fat and sugar also heat up in a microwave. They too have polar molecules that are forced to dance by the oscillating field, though not as efficiently as water. The microwave is not a source of heat. It is a source of motion. The heat is a byproduct of that motion, created within the food itself. So where does the heat actually come from? The answer is a word you know very well: friction. When all those trillions of water molecules are vibrating billions of times per second, they bump into their neighbors. They jostle and slam against each other. All of this bumping and colliding creates friction, and friction generates heat. The energy of motion, called kinetic energy, is converted into thermal energy. This is why the food gets hot from the inside out. The energy is not being applied to the surface. It is being generated deep within the food wherever water molecules exist. The waves penetrate an inch or two into the food, starting this vibration process deep inside. The heat then spreads from those points to the rest of the food. Microwaves pass right through the plate without having many polar molecules to interact with. They save all their energy for the water in the food. This also explains the turntable. The wave pattern inside the oven is not perfectly uniform. There are hot spots and cold spots. The turntable rotates your food through these different spots, ensuring that all parts of it get exposed to the energy and cook more evenly. This reflection can cause the waves to concentrate in one spot, overwhelming the magnetron or creating electric arcs, which we see as dangerous sparks. So a dry paper towel is safe because it has no water to heat up. But a wet paper towel will get very hot very quickly. Even the instruction to let food stand for a minute after microwaving makes sense now. This allows the heat generated in the watery parts to spread to the drier, cooler parts. The big insight here is beautifully simple. Microwave oven is not a heat ray. It is a molecule shaker. It uses invisible energy to command the very molecules of water in your food to vibrate, creating heat through friction right where it is needed most. This is a profound idea. We are not adding heat to food. We are telling the food how to create its own heat using the laws of physics. It is a perfect example of how science and engineering allow us to control invisible forces to make our everyday lives easier, faster, and more efficient. The next time you heat up your leftovers, you will know the truth. You are not just pushing a button. You are unleashing a silent, invisible, high-speed dance of molecules.